Are we recording? Okay. Hey guys, welcome to our Team Teach. This is our third one, Module 3, Chapter 4 and 5. We have number theory and integers. Okay, and I'm Miranda Curtis.
And I'm Laquela Roberts.
Okay, and we are going to go ahead and get into our first question. Let's go click crazy. Okay, Miss Dominique. Oh, where'd it go? Okay, so our first question. Use the divisibility test to describe which of the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is a divisor of the numbers in the left column of the following table. Number 684 is done for you. Okay.
All right.
Let's get it.
Here I go. So as you see, we have our table here. And as how you would get the answers to see if they're divisible, you'll do 684 divided by 2. And yes, it is most definitely divisible by 2. It's divisible by 3. It's divisible by 4. It's not divisible by 5. It is 6, not 7, not 8. It is 9, and not 10 and 11. And so forth. You will do the same exact thing with the same numbers across here. You're just going to divide by each of the numbers to see if they all match. And if they don't match, this is how we get it right here. All right, Miranda, demonstrate the use processes of nines to check each of the following answers. Question 2.
Okay, so to start with, we're gonna go to our little help bubble, and this is gonna help us get through this. It says, to solve the problem, go first to the first line. When you see a 9, cross it out. So our first line is 4, 1, 6. We do not have a 9 in there, so we do not have to cross it out. The next step is to look to see if any of the numbers in the line add up to 9. If they do, mark them out. 4 plus 6 plus 1 equals 11. They do not equal 9, so we do not have to cross them out. Then you have to add them together, and that will give you a remainder. So 11, we put 1 plus 1 equals 2. So at our top line, that's what we do. Okay, so we're going to go to the next line. We have a 7, a 4, a 9, and 0. I see a 9, so it's got to be crossed out. So we have a 7 and a 4, and it does not equal 9. So you have 20. So we're going to plus 2 plus 0 gives us a remainder of 2. Now we're going to go to the next line. 6, 9, 8, 4, 4. There's the 9. We got to cross it out. Okay, none of the other ones equal 9. So 6 plus 8 plus 4 plus 4 equals 31. We're going to do 3 plus 1, and it gives a remainder of 4. Now we're going to go to the bottom. Now we have 1, 1, 2, 7, 9, 0. We have a 9. We're going to cross that out. And 7 plus 2 equals 9. We're going to cross that out. So we have a 1 and a 1, and we're going to plus it together. It's going to give us 2. Now, when we try to check, we got to actually add it all together, because this is not the right answer when you add it all together. And so when we add it all together, it's going to give us, one more click. There you go. 77,750. Now, we're going to do the same thing we did with the others. We're going to look for 9. There's no 9 in that bottom. So what we're going to do is 7 plus 7 plus 7 plus 5. And that is going to give 14, 15, 16, 17, 18, 19, 20, 22. And then 27. So 2 plus 7. And then, oh, it is 9. But what we're going to do, if our correct answer gives us a remainder, if it's the same remainder as the other one, then it's correct, but it wasn't. So we're going to go to the next question, Ms. Dominique. Again, we're going to demonstrate the process of 9 to check each of the following answers.
Okay, so how you would do here, you would add up, this is what we have, 8,550 plus 6,888 plus 2,525 plus 6,029 equals 23,892. Well, we don't know if that's true or not, so let's do some work. So we got 8 plus 5 plus 5 plus 0 equals 18 with the remainder of 2. And then we have 6 plus 8 plus 8 plus 8 equals 30 with the remainder of 3. So what you're doing, we're breaking these numbers down. Then you have 2 plus 5 plus 2 plus 5 equals 14 with the remainder of 5. 6 plus 0 plus 2 plus 9 equals 17. 3 plus 5 plus 8 equals 16. So we got 2 plus 3 plus 8 plus 9 plus 2 equals 24, remainder of 6. So that equation is incorrect, okay? So here's the right answer to our problem. You add 8550, 6888, 2525, 6029, and it gives us 23,992. So this is our correct equation. All right, Miranda. Demonstrate the use process of nines to check each of the followings again.
Okay, so now we're going to subtract. We're going to use the same rule, and we're going to roll out our nines. So we have 78362 minus 3674 equals 74678. Do we know it's true? No, we have to check. So what we're going to do in the top is we see that 6, 7, 8, 9, 6 plus 3 equals 9. So we cancel that out. Then we see 7 plus 2 equals 9. That gets canceled out. So what we're left with is 8 plus 0 equals 8 and gives a remainder of 8. Now we're going to go to the next line. We have 3, 6, 7, and 4. 6 plus 3 equals 9. So that's canceled out. So now we're left with 7 plus 4. And that's going to give us 11. Now we're going to do 1 plus 1 equals 2 gives us a remainder of 2. And then we're going to look at the bottom. One more click. Okay. We're going to have 7 plus 4 plus 6 plus 7 plus 8 equals 32. When we add that together, 3 and 2 gives us 5 and gives us a remainder of 5. But the answer is incorrect because that is not what that equals. We're going to come over here and we're going to subtract it you can use your calculator or your phone, or you can do it by hand, and it's going to give us 74678. So we know that is the correct answer. Now, Miss Dominique, let's use the process of 9 to check this next equation.
All righty. So we have with multiplication that we're working on, and we have 337 times 620. So it's telling us it equals to 209,940. Well, in order for us to know that for sure, we got to break some things down. So we're going to break down 3 times 3 times 7. That gives us 63 with the remainder of 21. So then we have 6 times 2 times 0 gives us 0, remainder 0. So again, our equation is incorrect. So get the right equation. You're going to do 337 times 620. You're going to get 208,940. Miranda, show which rods will measure the non-rod.
Okay, we're going to look at our factors. What will equal 9? Okay, we're going to come over here. We look at our rods and we look how big they are, and they look very scary. And then we're going to break it down. So 9 times 1 is 9. 3 times 3 is 9. So these are the rods that are going to give us 9. And
wow,
they will measure our time for us. Okay, Miss Dominique, show which rods will measure the 6th rod.
All right, so as you can see, our factors of 6 include 1, 2, 3, and 6. So 1 times 6 is 6. 2 times 3 is 6. So as we can see, 1, 2, 3, and 6 rods can be used to measure the 6th rod. Miranda, use parts A and B to show the greatest common divisor of 9 and 6.
Okay, so we already went through 9 and we had 1, 3, and 9 because 1 times 9 is 9 and then 3 times 3 is 9. And then Miss Dominique showed us in the last question, the factors of 6 is 1 times 6 and then 2 times 3. So we click one more, that gives us 3 because 3 is in 9 and is in 6. Miss Dominique, show all the links. Oh wait, wrong one. Place the 10 rod and the 8 rod end to end from an 18 train. Show all the rods or trains will measure in the 18. Recall that a train is formed when one or more rods are placed end to end.
Here we go. So as you can see, the factors of 18 includes 1, 2, 3, 6, 9, and 18. All right, so that means 18 times 1 is 18. 2 times 9 is 18. 3 times 6 is 18. So the 1, 2, 3, 6, 9, and 18 rods can be used to measure the 18 rod. So easy. Miranda, demonstrate how you might use these color rods to demonstrate the notion of greatest common divisor to children.
Okay, one more clip for me, please. Okay, the greatest common divisor went somewhere. Okay, how we show the greatest common divisor of the two numbers R and S is the length of the longest train or the rod that will measure both the R train and the S train, like our 18 that Miss Dominique showed us last time. And like we have 9 that we had in our first equation. So that is going to give us our greatest common of the two numbers. Okay, Miss Dominique. The LCM method demonstrated in the table to the right is as followed. Factored out any prime divisors of one or more terms and replace each term containing the prime factor by its quotient. Continue until the last row contains only distant prime numbers 1. Then multiply the exact prime in the primes in the last row to obtain the prime number from the LCM. The method works equally with any number. The table will compute.
All right. Here we go. So as you can see, our table is right here, right? So we have our lowest common multiples, which is 48, 25, and 65, okay? So 48 divided by 2 is going to give us 24. 24 divided by 2 is going to give us 12. 12 divided by 2 is going to give us 6. 6 divided by 2 is going to give us 3. 3 divided by 3 is going to give us 1. And 1 and 5 and 1. So that's what you would do with 25. 25, it doesn't go by 2s. It doesn't go with 3. It goes with 5. 5 times 5 is 25. The same with 65. It doesn't divide into 2 or 3, but it will divide into 5. So we have 1, 5, and 13. Our prime factorizations is 2 to the 4th times 3 to the 1st times 5 to the 2nd times 13 to the 1st. Miranda, demonstrate the use of this method to find the lowest common in parts A through C in prime power form.
Okay, so as Miss Dominique showed in hers a second ago, we're gonna do the same thing over here. So we have 40. So 4 times 10 gives us 40. You're gonna bring down 2 times 2 equals 4. We stop right there because 2 is of itself. And then we have 10. So we have 5 times 2 equals 10. Again, they stop right there. Then we're gonna go to 12. 6 times 2 is 12. Okay, 6 still has, we have to break it down to 3 times 2 where it stops. Okay, then we come to 44. 4 times 11. 11 stops right there because it doesn't go any further to break down. Now 4 is 2 times 2. Then we go to 363. 3 times 121. We stop at 3 because it won't break down any further. 121 is 11 times 11. Now what we're going to do is bring them down. Okay, 40, you have 1, 2, 3 2s right here. Okay, you're going to put 2, and then you're going to have a 3 at the top. You're going to bring down your 5. You don't know if that's the number just yet. Then we're going to come right here. We have 2 2s right there. Okay, we already have 2 3s down, so it's already divisible. We're good. So 12, we have 1 3. So we had to bring that down so it could be divisible by that. So we have a 1. Now 44, there's 2. We're good. We already have 2 2s in our factorization. We have to bring down this 11 because we haven't had it yet. So now it'll be divisible by it. Now we're going to go to our next number. We already have 1 3, but look, we have another 11. So we have to bring it down. So that leaves us 2 to the third times 3 to the first times 5 to the first times 11 to the second equals 1,320. Miss Dominique, demonstrate the use of the method to find the LCM in our next part C.
All right, so as we got our lowest common multiples, 250, 28, 44, and 110. So as you can see, 250 has 2, 5, 10, 25, and of course, 50. 28 has 2, 4, 7, and 14. Because 2 times 14 is 28, and 4 times 7 is 28. 44 has 2, 4, 11, and 22. 110 has 2 times 55, 5 times 22, 10 times 11. So our prime factorization for this problem is 2 to the 4th times 5 to the second times 7 to the first times 11 to the second times 55 to the first. All right, Miranda, in a machine, a gear with 48 teeth is engaged with the gear with 84 teeth. With teeth A and B on the small and large gears, demonstrate how many revolutions the small gear will have to make before A and B are again in the same position. Question 5.
Okay, Ms. Dominique, just like she just did a minute ago, we're going to break down these numbers. This is going to be the easiest way to do this because you can sit there and keep multiplying until you get the highest factor of each that equals the same. But here's a way to break it down and make it fast. So we have 84, we have 2 times 42. 2 again cannot break down because it's already in its lowest form. 42, we have 2 times 21. And then we have 21 right there. So we have 3 times 7. If you click one more time for me. Now we're going to break down 48. Okay. We have 2 times 24. We're going to break down 24. We're going to have 2 times 12. We'll break down 12. We got 2 times 6. We're going to break down 6 to 2 times 3. So what we're going to do, like we did in our other one, we're going to bring down our 2's. 84 has 2 2's, so we have 2 2 so far, but we have to look at 48, and you have 2 more 2's. So it's going to give us 2 to the 4th. Now we have 1 3 and 84. We're going to bring down the other. We already have a 3 over here in 48, so we only need 1. We have 1 7 and 84. We're going to bring down. And so what it's going to give us is 2 to the 4th times 3 to the 1st times 7 to the 1st equals 336. Give us lowest common multiple of both. Now what we're going to do is we're going to divide the lowest common multiple, which is the LCM, and we're going to divide the 48 here because that is going to give us how many rotations we'll give. So it's going to give us 7. 7 is how many rotations. Okay, Miss Dominique.
I like how you did that and how you broke it down to make it a little easier to understand of how the rotations and all that goes. I really like that. Good job.
Thank you, because it took me half an hour to do it the other way. Miss Dominique, demonstrate how to create a magic square using the following integers: -7, -6, -5, -4, -3, -2, -1, 0, and 1.
All right. So as you see here on our table, we have 0, -7, -2, -5, -3, 1. Because those two, the 0 and the 1 was the ones given to us, and -4 and 1 and -6, we had to figure out. So when you add them, you do -7 plus -6 plus -5 plus -4 plus -3 plus -2 plus -1 plus 0 plus 1 will give us -27. So we're going to divide -27 by 3, and that's going to give us 9. So our magic number for this problem is the number 9.
So guys, thank you for watching our video. This is the end. And Miss Dominique, you know we're going to see you the next lesson. We're going to have fun with this.
Yes. Thank you, guys. Bye.